Right now, as you're watching this video, you are moving. Not just spinning with Earth. Not just orbiting the Sun. Your entire galaxy, the Milky Way, is moving through space at more than 1,000,000 miles per hour. And here's the strange part. We are not moving randomly. Our galaxy is part of a huge cosmic flow, with thousands of other galaxies moving in the same general direction. Something massive is influencing that motion. Astronomers call the region responsible for this gravitational pull the Great Attractor. And for decades, there was a problem. We couldn't see what was behind it, because the Great Attractor lies in a direction where the disk of our own Milky Way blocks much of our view. It's a cosmic blind spot. And today, we are going straight into it. Okay, so first, how do you even discover something you can't see? Back in the 1970s and 80s, astronomers were mapping the motion of galaxies across the universe. And they noticed something weird. Galaxies weren't just moving with the expansion of the universe like they were supposed to. They were drifting sideways, off pattern, like something with serious gravitational muscle was tugging on them. This wasn't some random blip either. Entire clusters of galaxies, thousands of them, were all drifting in the same general direction, our galaxy included. By the 1980s, astronomers had a name for this collective motion, the Great Attractor. Here's the thing that makes this legit, not just internet space lore. This isn't some fringe theory. We know there's a real, large-scale gravitational flow in that direction. The harder question scientists are still working out is exactly which structures are responsible for it, and how much each one contributes. You'd think with all our telescopes, we'd just point one at it and boom, mystery solved, right? Nope. And the reason is honestly kind of poetic. The Great Attractor sits almost directly behind the flat disk of our own Milky Way, from our point of view. And our galaxy's disk is packed with gas, dust, and stars that block visible light almost completely in that direction. It's like trying to see through a wall while you're standing right next to it. This blind spot is literally called the zone of avoidance, and for decades, it made this region one of the most understudied parts of the observable sky. To get around it, astronomers had to get creative. They started using X-ray and infrared telescopes, which can punch through dust way better than regular optical light. And using those tools, scientists slowly started piecing together what's hiding back there. Here's where it gets genuinely wild. Using X-ray data, astronomers identified a massive concentration of galaxies in that region, now known as the Norma Cluster, roughly 250 million light-years away. But here's the plot twist. The Norma Cluster alone isn't massive enough to explain the full pull scientists are measuring. It's a big player, but it's not the whole story. So what's the rest of the answer? In the 2010s, a team of astronomers mapped an even bigger structure surrounding the Great Attractor region, something they named the Laniakea supercluster. Laniakea is Hawaiian for immense heaven, and trust me, the name checks out. Laniakea contains roughly 100,000 galaxies, stretched across 500 million light-years, and our entire Milky Way is just one tiny galaxy inside it. We are, quite literally, a small suburb in an unimaginably massive cosmic city. The Great Attractor region lies within this broader structure, and its gravitational influence is part of the large-scale flow we observe. So to be clear on what's confirmed here, we know there's a massive concentration of galaxy clusters in that direction. We know it's part of a real, measurable gravitational flow. That part is solid science. What's still debated is exactly how much of the pull comes from Laniakea's visible galaxies versus other structures further out. Okay, so here's where things get genuinely unsettling. Even after mapping Laniakea, some scientists notice something odd. The pull on our galaxy, and thousands of others around us, seems stronger than Laniakea alone could produce. That led to a bigger, even more mind-bending hypothesis. Something researchers call the Shapley supercluster, located far beyond the Great Attractor, might be exerting an even larger gravitational influence, potentially pulling on the Great Attractor itself. If that's true, it means we are not just being pulled toward one mysterious point. Think of it less like a chain reaction and more like layers of gravitational influence. Structures pulling on structures, stacked across unimaginable distances. To be clear, this layered structure is still an active area of research, and scientists are refining these models using newer, more precise galaxy surveys. Shapley shows up as a significant X-ray structure in the direction of the Great Attractor, which is why it keeps coming up in this conversation. Kind of a lot to process, NGL. Okay, I know what you're thinking. Are we about to get sucked into some cosmic void of doom? Short answer, no. Chill. Here's why. This isn't a black hole. It's not sucking us in like a drain. It's a massive concentration of mass, galaxies, gas, dark matter, creating a gravitational flow that nearby galaxies naturally drift along, kind of like water flowing downhill. And the timescale here is absolutely massive. We are talking about a journey that unfolds over billions of years. Nothing about your day, your week, or honestly even human civilization is affected by this in any noticeable way. But here's what it does tell us, and honestly, this is the part that hits different. Our galaxy isn't just floating around randomly. It's part of a much bigger structure, a cosmic web of superclusters, voids, and filaments, and we are being shaped by forces we can't even fully see yet. That's not scary. That's kind of beautiful, actually. So why are scientists still obsessed with this decades later? Because the Great Attractor is basically a live case study in one of the biggest open questions in cosmology. How is matter actually distributed across the universe, and what's driving its large-scale motion? New surveys, using next-generation radio and X-ray telescopes that can see straight through the zone of avoidance, are actively mapping this region in far more detail than ever before. Every year, we get a slightly clearer picture of what's really back there. And that matters, because understanding structures like Laniakea and the Great Attractor helps scientists understand something way bigger. How galaxies, including our own, form, evolve, and move across cosmic time. So next time you look up at the night sky, remember this: everything you're seeing, every star, every galaxy, is on the move. Being pulled, slowly but surely, by forces we still can't fully see. We know the pull is real. We know it's massive. But we are still filling in exactly how it all fits together. And honestly, that's what makes space so addictive to explore in the first place. If you want to keep chasing mysteries like this one, hit subscribe to Deep Space Files, because the universe is full of things hiding in plain sight.